All right, so this is our first section where we're talking about proofs, and we're going to start with algebraic proofs. Basically, what we're going to do for this lesson is just do one-step operations, two-step operations, and provide reasoning for everything that we do. So the objective is to review properties of equality and use them to write algebraic proofs, and then identify properties of equality, and vocab word is going to be proof. Let's go ahead and make that the first buzzword. And your only buzzword is going to be proof. A proof is an argument that uses logic, definitions, properties, and previously proven statements to show something is true. Or what they say, a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. Conclusion, something, same thing. An important part of writing a proof is giving justifications to show that every step is valid. If you're going to say something is true, you have to show why it is true. So copy down this table. This is the properties of equality. So it should make sense. If you're good with algebra, this shouldn't be an issue at all. This is saying if A equals B, then if I add some value to A and I add it to B, I should be fine. So if 1 equals 1, if I add 2 to both sides, I get 3 equals 3. This tells me I can add things. Addition property of equality tells me if I add it to the left side and I add it to the right side, it stays equal. That's what it's basically saying. It's the equal sign is the key thing here. If I add something to the left and I add it to the right, it's still equal if I add that same amount. So subtraction property, if I take away an amount from the left side and I take it away from the right side, it stays equal. Multiplication property of equality, if I multiply both sides by the same thing, it stays equal. Think of like you're holding a scale. If I multiply the left side by C, or let's just say 2, if I multiply the left side by 2 and I multiply the right side by 2, if the scales are even, they'll stay even. Division property, as long as C does not equal 0, because we can't divide by 0, if C is divided by A and B divides by C, then those are going to be equal. This is a new one. It's called the reflexive property. We're going to call this the duh property. It tells us A equals A. Reflexive property says A equals A. That's duh. We call that the duh property. Everybody knows A equals A. It will be helpful later on to use that. Symmetric property, we're going to think of the mirror property. If A equals B, then B equals A. You just flip-flop it around like a mirror. Transitive property is similar to the law of syllogism. If A equals B and B equals C, then A equals C. So we have A equals B and B equals C. So it crosses out both of them. So if white girl equals Starbucks, or Starbucks equals white girl, and white girl equals Uggs, then Starbucks equals Uggs. Substitution property, it tells me if A equals B, then B can be substituted for any A in the expression. So if I tell you X equals 4, anytime I see a math equation with X, I can put in a 4. That's all it's telling me is I substitute. Don't forget the distributive property. This is not part of the equality properties, but do go ahead and write this below that table. That just tells me if A is on the outside of the parentheses, I can multiply it into both of them. All right, so example 1, solve the equation 4m minus 8 equals negative 12. Write a justification for each step. So I'm going to go ahead and start our first two-column proof. All the proofs that we do in here are going to be two-column proofs. So I have 4m minus 8 equals 12, negative 12. This is called our justification. We're going to put our, let's see, I can't. We're going to put our steps over here on the left side and our justifications or reasonings over here on the right. 4m minus 8 equals negative 12. That is given to us, so our justification is given. When you do a two-column proof, this box will always, 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 always say what is given to you. You always write here what they give you, and then here you write the word given. If they give you multiple things, you write all of those things in this box. All right, so now we're just solving for m. So what I'm going to do first is I'm going to add 8 to both sides. And then my reason, if I add it to this side and I add it to, we all know why we're adding 8. Since I'm taking away 8, I need to add 8 to get rid of this. So this is, since I added 8 to both sides, it's called the addition, I'm going to abbreviate this, addition property of equality. Okay, so then I simplify. 4m equals negative 4. That step is called simplify. Now I'm going to divide this out by 4 and 4 because I want to get rid of this m. I want to get it alone. And that's called the division property of equality. Divided by 4 on the left side, divide by 4 on the right side. Nothing changes, so it's all cool. M equals -1, and the reason for this is simplify. So if you're able to follow along with that, you just did your first 2-column proof of geometry. If not, go back and double check. This part should not be the confusing part. We should be able to solve for m equals -1. If I gave you this, you should be able to solve for m equals -1. This part's what's new. We're adding justifications. Okay, example 2. Solve the equation 1/2 t equals -7. Write a justification for each step. So again, steps and justifications. So we have 1/2 t equals -7. Again, this is given to us, so we just write that it's given. This is positive. Let me erase this. 1/2 t equals -7. Okay, so I'm multiplying by I'm multiplying / dividing by 1/2. So what I'm going to do to get rid of a fraction of 1/2, I can multiply it by 2. Multiply by 2 on both sides. So this would be called the multiplication property of equality. These cancel out and I get t equals -14. And that simplify is the reason for this one. It's pretty easy. Alright, like algebra, geometry also uses numbers, variables, and operations. For example, segment lengths and angle measures are numbers, so you can use these same properties of equality to write algebraic proofs in geometry. So what this is a segment, a line segment, AB. So a number AB represents the length of the segment AB. Since this has a line above it without arrows, this represents segment. This is going to represent the actual value of the segment. So if I measured it out with a ruler and it was 3 inches, this would be 3 inches. So you could think of the measuring of AB as a number or variable representing a number. So for example, example 3. Solve for x and write justifications for each step. So what I'm going to do is set up a 2-column proof. I've got steps and reasons or justifications. And the first thing is nothing's given to me. The values were given to me, but that's not what I'm going to start with. What I'm going to do is start with how do we do this in chapter 1? We would take the red information, add it to the blue information, and set it equal to the green information because it's the whole length. So what I'm going to do is I'm just going to write that down. So NM plus MO equals NO. You have to write down everything. And the reason for this is, why this is a true thing, is because of segment addition postulate. All right, next, I'm going to write 2x plus 3x minus 9 equals 4x minus 4. The reason for this is substitution. I just subbed in my values. I went from this line to this line just by substituting. I had NM plus MO equals NO because segments add up to be the whole segment. NM was 2x, MO was 3x minus 9, and NO was 4x minus 4. Now I'm just going to combine all my terms. So let's do that. I've got 5x minus 9 equals 4x minus 4. The reason for that is simplify. Now I'm going to subtract 4x over to the other side. So this is going to be subtraction property of equality. X minus 9 equals -4. Another simplify step. Now I'm going to add 9 to both sides. This is the addition property of equality. X equals 5 by the step simplify. So I have solved for x with justifications for each step. Example 4, write a justification for each step. This is the same thing as the last one. So, except now we're dealing with angles. We have our steps and reasons. So I'm going to say angle ABD plus angle DBC equals angle ABC by angle addition postulate. Okay, so you should be able to remember how we just did the last one. Now I have 3x plus 5 plus 6x minus 16 equals 8x by substitution. 9x minus 11 equals 8x. Simplify. Subtract 9x from both sides. Subtraction property of equality. Negative 11 equals negative x. Simplify. Divide by negative 1 on both sides. Division property of equality. 11 equals x. Simplify. That's all you do. You just set up your problem as if you were solving it without the justifications, and now you just have to say why you're doing what you're doing. So you learned in chapter 1 that segments with equal lengths are congruent and that angles with equal measures are congruent. So the reflexive, symmetric, and transitive properties of equality have corresponding properties of congruence. So same thing with our numbers, you can just add angles. So the properties of congruence, again, please write down this table. This is the same thing as we said earlier, but now we can apply these with angles and segments. So if figure A is congruent to figure A, then the EF is congruent to EF. Symmetric property of congruence. If figure A is congruent to figure B, then figure B is congruent to figure A. That's the symmetric property. So you just reflex it. So these are the how you would symbolize it. And these are examples. So EF is congruent to EF. That would be an example of how you would write a reflexive. Angle 1 congruent to 2, then 2 congruent to 1. That's a symmetric. And then last, transitive. These should seem familiar from what we just did in chapter 1 or in the previous sections. All right, and this is super, super, super key important. Write this down, box it, start, highlight it. Numbers are equal and figures are congruent. A lot of times you will write the wrong symbol for the wrong thing. You and your neighbor are not equal. You may have equal heights, but you are not equal. You are congruent. So if I'm measuring everybody's heights and put them all in order, the person you're standing next to could be congruent to you, the actual people. So here's Bob and here's George. They are congruent, but they are not equal. They may both be 5 feet. Their heights are equal. The people themselves are not equal. So the people are congruent, their heights are equal. So it's kind of like an angle. Angle 1 and angle 2 are congruent. The angle itself, the figure, the measure, if this measures 45 degrees and this measures 45 degrees, the measures are equal. Figures cannot be equal. Figures are congruent. Measures are equal.